and the second analytic. And leave that exercise to you. Okay, so first, what you have to do is writing F in the polyphase form, which is look like this. Okay, F with the F even, Z square, the Z inverse, and R of Z square. And then we use the second double identity to switch the operation like that. Okay, again, so this has 10 multiplier, and you do 10 multiplier per unit time, right? But here, you see that this is 5, 5. So you're doing here, you're doing at low rate. Right? So this is 10 unit time here, twice the rate. This is twice the rate. And then you have to do, or only do it at the original rate, and then you interlace them. This process, what we have discussed over here, right? This erase. Basically, take the two signal, we interpolate, right? We upsampling, and then interlace them like that. So that's just parallel to serial conversion. And you never do it like this. You basically pick out the vector to serial, right? You only basically pick out the operation. And this is the opposite of this, right? This is serial to parallel. This is parallel to serial. Okay, here we block the input into vector. Here's we deblock. Go from vector back to a string of numbers, a sequence. Okay? Let's say Z to the minus 5. That's my Z transform. Okay? Let's see how to find the even polyphase and the odd polyphase. Look at this form. What do I have? What did it say here? All the even power of Z go to this guy. All the odd power of Z go to here. Right? Because that will be even. Z inverse is odd. I'm going to take this Z transform. I will have two groups. The first group will be even power of Z only. Second group, only odd power of Z. I factor out Z inverse to get that form. Okay? You need to help me. Where are power of Z here that's even? 1. Only one of them, right? How about the odd one? The factor out Z inverse. What is that? 2. So 7, Z to the minus 2. And 8, Z to the minus 4. So as it is now, I have the polyphase form, right? Yeah. Even of Z square, Z inverse is out of Z square. So tell me what is H even of Z? 1. Just 1. What is H R of Z? 2 plus 7 Z inverse. Right, because this is Z squared. 8 Z to the minus 2. That's how you do it. This is H R of Z squared. X out of Z. Suppose this is what I'm going to do in the analysis. How do I reconstruct? What's the filter here? What is H naught? X naught is 1, right? Remember filter bank, we have H naught, H1, right? H naught is 1, H1 is 1. Z inverse. Okay? 1 Z inverse. So this is very simple system. Okay, just one delay. How do I reconstruct? Of course, you can do half band and so on and so forth. Let's not do that. Let's think about that. What's going on here? What is that? Parallel, a serial, to parallel, right? How do I get back the signal? So just interlace. So you take this up by 2, up by 2. Is that right? This is actually this is Z. Z inverse. Is that right? So yeah. So let's think. X0 here, X1, X2 coming here, right? Over there will be X0, X2, here will be 0, X1, X3, and so on. What is that? X0, 0, X2, 0, here, 0, 0, X1, 0, X3, 0. No, I need to delay the other way. Right? Okay. Right? If I do this, then I have x of n minus 1. You see that this system here is very, very simple. You get perfect reconstruction. Okay? The filter here are 1, Z inverse. Z inverse 1. It's not very useful, but it is PR. Okay? This is called lazy filter bank. It doesn't do anything. Right? It is actually a perfect reconstruction filter bank. What is the input coming in? That delayed by one sample. Okay? You will see the polyphase look like this. So let me search for it. Okay? Are there any questions regarding PR now? It is PR, right? What if I insert something in the middle? Okay, so here's how I do it. I do exactly the same form. I want to insert in the middle a block. So this block is identity. Then it doesn't change anything, right? Okay? Instead of one block, I'm going to have two blocks. One block here, another block here. If this block are invert of each other, then it's still okay. Right? So I choose U and U inverse. But U is an arbitrary 2 by 2 matrix, real coefficient. This product